Welcome to the first module of our course on Introduction to Cloud Computing. In this module, you will learn what cloud and cloud computing is. You will understand the evolution of cloud computing, as well as the difference between on-premise and cloud, as well as how it revolutionizes IT infrastructure. So let us dive in and explore the foundations of this transformative technology. The first thing we'd want to understand in the cloud world is what exactly is the cloud? Well, let us put it this way. The cloud can be referred to servers that are accessed over the internet and the software and databases that run on those servers. And so the cloud servers are typically located in data centers that are spread all over the world. And so with that definition, what are some of the key characteristics of the cloud? Well, some of the key characteristics of the cloud are on-demand self-service. What does this mean exactly? This means that users can provision computing resources as needed and in an automated fashion without requiring human interaction with the service provider. Another key characteristic of the cloud is resource pooling. What we call resource pooling is a situation where the provider's computing resources can be pooled to serve multiple customers across the world using what we define as a multi-tenant model that has different physical and virtual resources that can be dynamically assigned and reassigned according to demands of customers or consumers all over the world. And so the cloud itself has various other characteristics such as measured services and rapid elasticity. Now, with all of that in mind, let us see what cloud computing is. Cloud computing can be defined easily as the delivery of various services over the internet. These types of services can include data storage, servers, databases, networking, and software. One very vital thing to know about cloud computing is that you only pay for cloud services you use. This ensures that you are able to lower your operating costs as an organization and that you are also able to run your infrastructures more efficiently and even well so, scale as your business needs those changes. It is very vital to know that there are three key components of the cloud computing, which is infrastructure as a service, platform as a service, and software as a service. However, we will get into those within our next modules. Now, what are some of the use cases of cloud computing now that we understand what cloud computing is from a basic definition? Some use cases of cloud computing can be for data storage and backup. In this case, we can easily store, backup, and recover data in the cloud. Another key use case for cloud computing is web hosting. With web hosting, we can use the cloud to host websites and web applications without the need for any physical servers. Another good use case for our cloud computing is development and testing. With the aid of cloud computing, we can quickly set up development and testing environments in the cloud for our different infrastructures and platforms. Another great use case for cloud computing can be for machine learning and artificial intelligence, abbreviated as AI. In this scenario, we can utilize cloud-based learning machines and AI services to build very intelligent applications. And so it is important to understand the basics of cloud and cloud computing as they are crucial for leveraging the full potential of cloud services. This fundamental knowledge of cloud and cloud computing would enable us to make informed decisions about how we can deploy, manage, and scale resources in the cloud effectively. And not to worry, as we go further in our courses, you will get to understand some of these key terminologies, such as deploying, managing resources, as well as scaling resources. Now let us jump into the origin of cloud and cloud computing. In the early days of computing, companies relied heavily on what we call physical servers and hardware which were located on their premises. Because these physical servers and hardware were located on premises, in modern day we call this on premises. And in our next slide, we will jump deeper into the definition of on premises and the difference between on premises and the cloud. And so, as businesses grew, so did their need for more computing power and storage. However, one major challenge they faced was scaling up was a very cumbersome and expensive process. However, during the 1990s, the internet began to revolutionize communication and information sharing. As such, we saw different innovators seeing the potential to use the internet to deliver computing resources more efficiently. However, one of the early pioneers was Salesforce, which in 1999 launched the idea of delivering what we call enterprise applications via a very simple website. This then marked the birth of what we call software as a service, which is one of the components of cloud computing. Around the same time, Amazon, a burgeoning online bookstore, faced massive scalability changes during peak and shopping seasons. So, to manage their infrastructure more efficiently, Amazon began to develop a robust, scalable architecture. This is because they realized the potential to offer this architecture as a service. As a result of that, Amazon launched the Amazon Web Services in 2006, providing the very first widely accessible infrastructure as a service platform. And so there was no denying that this was a big game changer. There were so many companies that no longer needed to invest heavily in physical infrastructures. Instead, these companies could rent computing power and storage on an as needed basis, and they had the ability to scale up or down based on demand. This pay as you go model was both cost effective and very, very flexible. This allowed businesses to innovate even much more faster. And so, following AWS success, other tech giants like Microsoft and Google entered the market with their own cloud offerings. Microsoft then introduced Azure in 2010, expanding beyond infrastructure as a service to even offer a more comprehensive range of cloud services, which included platform as a service and various software as a service solutions. Google Cloud Platform then followed suit by bringing its own expertise in data and machine learning to the cloud. And so the term cloud computing became widely adopted to describe the delivery of various services over the internet. As such, in today's time, cloud computing is now an integral part of modern IT landscape, driving innovation in every industry. It now allows businesses of all sizes to leverage powerful computing resources without the traditional constraints of physical infrastructure, paving a new way for new technologies and business models. And so, as we see the evolution of how cloud computing formed, we can see that it started from mainframe computing to SMP and open systems, and then to distributed computing, grid computing, and then finally in the late 2000s, cloud computing. And so let's take a quick definition of what these individual components mean. The mainframe computing is a centralized process with very powerful singular machines. The SMP open systems are multiple processors working together within a single system. The distributing computing are tasks that are spread easily across multiple interconnected machines. The grid computing are large-scale resources sharing across distributed systems. That means that the grid computing involves connecting multiple computer systems from different locations to work on a single task, thereby leveraging their combined process power for large-scale, resource-intensive problem solving. This sort of setup for the grid computing allows for efficient resource utilization and high performance of computing systems across a distributed network. And then finally, we come across our cloud computing, which is an on-demand scalable resource provided over the internet. And so when we look at that breakdown of the cloud computing, we can see that it started from our mainframe computing back in the 60s and then progressed into SMP open systems, which allowed for our multiple processors. And then came the birth of distributed computing, which gave the capability to spread tasks across multiple machines. And from there, we had the grid computing, which enabled organizations to harness distributed resources to achieve large-scale tasks. Finally, all of this came to the culmination of cloud computing, which in modern day and time provides scalable, on-demand, internet-based resources. And so, with that understanding of the evolution of cloud computing, let us take a look at the difference between what we call on-premises and the cloud. Our on-premise can be defined as an IT infrastructure that is physically located within a company's own facility. This is so that those facilities can be managed and maintained by the companies itself. And so our on-premises refer to what we call physical data centers. These are typically data center facilities that are not essentially owned by popular service providers such as Amazon, Google, or AWS, but are rather owned by individual companies or organizations. And so this is totally different from our cloud service providers such as AWS and Azure that have full control of their data center locations instead of organizations and companies. This clearly marks the difference between the on-premises and the cloud, where on-premises are facilities or data centers that are owned by organizations or companies that manage and maintain those facilities themselves. Whereas the cloud service providers such as Amazon, Azure, and Google manage and maintain their cloud data centers. The key difference to know between on-premise and cloud is that with the on-premises, the hardwares and softwares are hosted on-site by specific organizations or companies, and those on-premises facilities require significant capital expenditure and in-house maintenance. Whereas with the cloud, the resources are hosted off-site by a third-party provider such as Amazon, Microsoft Azure, and Google. This thereby reduces the need for physical infrastructure and maintenance by organizations, companies, or individuals that utilizes these cloud resources. And so, in the summary of our introduction to cloud computing, it is very important to know that in today's world, cloud computing has now formed an integral part of the modern IT landscape, enabling businesses to innovate rapidly without the constraints of physical infrastructure. The cloud's evolution from on premises hardware to internet based services has truly transformed industries and made powerful computing accessible to anyone with an internet connection. And so let's talk about some of the top benefits of cloud computing. One of the very key aspects of cloud computing that most organizations and businesses benefit from the most is costs. With the move to cloud computing, businesses can really leverage from managing costs very effectively. Because as opposed to on-premise servers where they actually have to manage physical servers, pay for the manpower to manage these physical servers, pay to sort of cover the specific area or data center, be it in terms of building the data centers physically or paying coverage to utilize a building center as a data center, companies tend to pay more for that. There's also the cost associated with transporting physical servers, maintaining the physical servers, as well as having to employ more people to set up and monitor these physical servers. And so with the cloud computing, you do not need to cover majority of all of those costs. This is because most of your cloud resources and services will be offered to you on the cloud, where the physical parts of the implementation of those cloud services and resources are taken care by a cloud service provider such as Microsoft. And so cost becomes a very big factor and plays in as one of the key business reasons for companies to want to move from on-premise to the cloud. And so because of this, cloud computing itself successfully eliminates the capital expenses we need in terms of those physical attributes of maintaining a data center, such as buying hardwares and softwares and setting up and running those on-site data centers. Another key aspect that is a great benefit when it comes to cloud computing is speed. So what do we mean by speed over here? Well, when we talk about speed in the cloud, we talk about the ability to provision and deploy cloud resources in a matter of minutes, if not seconds, for some cloud resources. To expatiate further on this, whenever you want to install a new set of server machines, say for example, you want to install 15 server machines within an on-premise environment, you would first need to place the order for these machines, have them shipped, have them physically set up and tested before they get up and running. Well, with the cloud, you don't need to do that. Basically, with the cloud, you go online to your cloud platform, such as Microsoft Azure platform, and then within a matter of minutes, you can easily provision the type of server machine or virtual machine you need. And in a short matter of minutes, those server machines can easily be provisioned and deployed and ready to be used without bothering about shipping physical hardwares, setting up physical hardwares, and getting the manpower to do all of those workload. And so speed becomes another top benefit within the cloud computing space, because majority of your cloud computing services are all self-service and are on demand. And as such, they are able to be provisioned in a matter of minutes. Another key aspect that benefits us a lot, especially within organizations or businesses at large, is that cloud computing comes with a huge advantage of performance. What this means is that because these cloud services and resources are managed by big cloud providers such as Microsoft,
They are able to take full charge of your cloud resources and enable regular upgrades to the latest generations of fast and efficient computing hardware for those cloud resources. Majority of this can also be done in an automated fashion, thereby relieving you of the stress of having to bring your cloud resources up to the latest generation of fast and efficient computing hardware, and leaving you to focus more on your business organization's structure and business goals. And so with that, your company does not really need to stress itself with trying to follow up with regular updates and upgrades to your cloud resources. Also, because you are getting these upgrades from the service providers directly, they take full charge and they're able to give you the very best of hardware services, which often would contribute to a continuous performance effectiveness of your cloud resource. And then another great benefit that relates closely with performance is productivity. Because on-site data centers and physical on-premise centers typically require lots of what we call racking and stacking of our hardwares, they also have to get involved with things like the hardware setup itself, software patching, and other time-consuming management costs. This, in one way or the other, hampers most organizations' productivity, because then they are not putting in 100% of their efforts on their business goals and agendas, as well as their business projects. They have to create the space, time, and manpower to manage all of those hardware workloads. But with the cloud, all of those things are eliminated. The organization can then focus largely on productivity for their organization, because cloud service providers take care of all of those. And as an organization, you do not have to manage any data center and all of the demanding activities that comes with managing multiple data centers or single data centers. And so productivity becomes a very key benefit for organization, whereby they can focus on the task that they need to do while leveraging the time that is being allocated to normally working within our on-premise, and they can now take that time to focus on more pressing demand and business needs. Now, the different types of cloud services that we really have are infrastructure as a service, which is over here, the platform as a service, and then the software as a service, which we will see in our next slide. Now, these types of cloud service really categorize the different high-level implementations as well as executions we can expect to meet when we work within a cloud platform. This one is the most basic category of all the different cloud computing services. It gives us the capability to rent IT infrastructures such as servers and virtual machines. It also gives us the ability to rent other infrastructures such as storage accounts, networks, as well as operating system, which we utilize and pay for based on a pay-as-you-go basis. And we often rent this sort of IT infrastructures from cloud service providers such as Microsoft Azure. And then we have our platform as a service. And our platform as a service basically refers to the different types of cloud computing services that can enable us to have an on-demand environment for delivering, developing, managing, and testing various types of software or web applications. This can comprise web APIs, web services, web apps, as well as mobile applications. And so it is safe to say that the platform as a service itself can easily make it easier for people like software engineers or developers, DevOps engineers, database engineers, and data analysts to sort of create different types of web applications, web services, and mobile apps. And they can now leverage the platform as a service to ensure that development, testing, delivery, and management of those software applications are done within the cloud and at scalable levels. The software as a service is a cloud computing service that can enable us to deliver software applications over the internet or on demand. And it can typically be a service where we pay based on subscription. And so with this software as a service, what really happens is that the cloud service providers can manage their software applications as well as host these software applications and their underlying technological infrastructures. They can also handle any sort of maintenance itself using the software as a service framework to perform actions such as software upgrades and security patching. The software as a service itself also too, when it comes to terms of working within the Azure portal as a cloud solution architect, it becomes the end product for utilizing things like our platform as a service and our infrastructure as a service. And so what does this really mean? It means because the software as a service is a subscription-based finished product service, it can be implemented using things like our platform as a service, where we can actually deploy and develop as well as test such applications, and then leverage on infrastructure as a service for our provisioning and deployment of those applications. And then they come out to become a software as a service such as our Office 365. And if you're familiar with things like Dropbox, these are examples of software as a services that can leverage off platform as a service and infrastructure as a service to come into existence as a software as a service product that bases its payment on subscriptions. And so we have a fourth item here, which is not part of the traditional cloud solution types of services, but is a new introduction of a subset of those areas as a service within the Microsoft Azure platform. And so we can see that our serverless computing overlaps with our platform as a service. And if you remember the platform as a service, we talked about it being a service that enables developers, engineers, DevOps to easily manage, develop, deploy, as well as test and manage software applications. And so the serverless computing comes in as a more lightweight infrastructure that enables a more extended way of working with our platform as a service solutions. And so within the Azure portal, you see the serverless computing where we will work with items such as function apps and container apps. And so to enlighten us a little bit more, this serverless computing will typically focus on building what we call app functionalities without spending too much time on a continuous need to manage servers and infrastructures that are required to achieve our app functionality development. This is because the cloud service provider themselves would typically handle all those setup, capacity planning, and server management for us.